information that comes available as the contamination issues are explored and data is collected. So that's why we're here. And specifically tonight, I'm going to be talking about a document that is being made available to you, the community, and it is a document to serve it as a resource for you. It's entitled East Palestine Train Derailment and Controlled Burn Environmental Data Review. So that kind of tells you in a nutshell what this document is about. It is a lot of data information in a format to be a resource for you folks to tap into to understand a little bit more about the contamination and the issues surrounding the derailment and the controlled burn. Before we dive into the document, a little background first. Let's revisit some background information as to understand where this document came from. Next slide, please. On February 3rd, a Norfolk Southern freight train derailed in East Palestine, Ohio. 20 of the affected cars contained hazardous materials, including vinyl chloride, ethylene glycol, ethyl hexyl acrylate, butyl acrylate, and isobutylene. Within hours, emergency response folks mobilized and began monitoring the environment to understand how to respond to the hazards. And in addition, EPA showed up shortly and started collecting samples and conducting monitoring to understand the contamination, targeting areas like the air and adjacent soils around the immediate proximity of the derailment. EPA contractors installed booms and underflow dams to try to restrict the flow of contaminated water and collect floating material to mitigate possible impacts to the nearby Sulphur Run and Leslie Run streams. Norfolk Southern identified that the vinyl chloride was possibly an explosive hazard, and so decided to conduct a controlled burn where the vinyl chloride was released to adjacent trenches and lit on fire. Prior to the controlled burn, however, the governors of Ohio and Pennsylvania ordered an immediate evacuation of surrounding areas to help control concerns and exposures. Next slide, please. Okay, so what happened after that? The derailed train caused a cascade of activity. Like I said, an emergency responders showed up on site immediately, and they assessed the site for their own health and safety, as well as the residents and the folks in the immediate area to determine just how much of a hazard was present. Emergency response workers focused on addressing the immediate hazards. And then, as part of the emergency response, federal and state agencies mobilized and began environmental monitoring of environmental media potentially affected by the spill and the controlled burn. These environmental materials, include air, soil, surface water, sediment, and eventually biological components, including plants and fish. Now, I want to pause right here because I want to describe several phases of monitoring and sampling that happen during an emergency response, such as this action. Initially, like I said, the emergency responders show up and need to immediately understand hazard or safety because they need to approach the site, and they also need to be able to tell the community what is happening and how to address the concerns. So within hours, emergency response, hazard identification, sampling, and monitoring takes place. And this usually is comprised largely of air sampling. Then from there, once we understand the hazard, what is the chemicals that have been released, just how much are we dealing with, then we embark on a different phase of monitoring and sampling, and that is what I refer to as characterization. Now that we know what we're dealing with, we want to take the next step to get our arms around where did the contamination go? Where are all the possible environmental materials that have been affected? Let's take a look at all the pathways that are potentially of concern and characterize the footprint, if you will, kind of the meets and bounds. Where all is the contamination? Because we want to make sure we sample everything possibly affected, and we sample and understand the footprint, like I said, of the spill, and also the controlled footprint the controlled burn release, which released ash and particulates to the air that eventually settled out into the soil. So that's characterization, and that monitoring and sampling takes on a whole life of its own because a whole lot of work is accomplished to basically, like I said, understand completely where is the contamination, how much are we dealing with, and do we fully understand the contamination. After that, we continue monitoring and sampling to verify remedy. So, for instance, at the spill site, a lot of material was removed. And you want to be sure that you remove everything you wish to have gone. So you take additional samples as you're moving along and removing materials to make sure your removal is complete. And this is called verification monitoring and sampling. So there's a lot of information being generated. Initially, there's all the sampling and monitoring to identify the hazard. Next came the characterization to understand the scope of the contamination and its footprint. And finally, the remedy sampling to verify that removal actions were complete. This is when the town of East Palestine requested assistance from TASC, Technical Assistance Services for Communities, because as they recognized, this represents a tremendous amount of information. It's just mind boggling how much is out there. And assistance is needed, and we are very much glad to provide that. So that's why we are here. Next slide, please. So the role of task, next slide. Task, as I said, is technical assistance services for communities. We help communities such as yours, communities affected by contamination released to their environment. We help bridge the gap in understanding. The folks that work on task programs often have a scientific background so that we can understand the data, why it's collected, how it's analyzed, and scrutinize the information from a community perspective. East Palestine officials requested that we get our arms around the publicly available information to describe the contamination that resulted from the spill and the controlled burn, and to conduct an in-depth environmental data review as an independent reviewer. As an example of the work that we've accomplished, immediately after TASC was brought on board, we were given the city park soils data where the East Palestine officials wanted to have an Easter egg hunt. And soil samples were collected out in the city park area to make sure that the soils were clean and acceptable for folks to come out and have their Easter egg hunt. So I took basically the analysis data from the soils that were collected, conducted my own review, and came back to the town and said, yes, things look good, the data is fine. Please proceed with your Easter egg hunt. So that's just an example. That was a bite-sized data interpretation that we provided early on. And then our efforts continued and bloomed, if you will, into the East Palestine Train Derailment Environmental Data Review. It's a sizable document that, like I said, was formatted to be a resource for you folks to take and understand the contamination and its impacts to environmental materials. Next slide, please. Report overview. Before I get too much further, I just want to give a little background about myself. I'm a technical advisor under the TASC program, and I'm a scientist. I'm an aquatic toxicologist with over 30 years of experience working on, hazardous waste sites, Superfund sites. My first project way back when was the Exxon Valdez oil spill, and I've worked on a long list of hazardous waste sites. So I've got a fairly good knowledge and understanding of contamination in all its forms. And so I bring that science background to you. But to be honest with you, I think my value as a technical advisor under TASC is that I have truly sat in your chairs or been in your shoes, so to speak, because I have lived within the footprint of two hazardous waste sites, the Leadville Superfund site in Leadville, Colorado. And then, if you recall in the news, the Gold King mine site release, that release actually rolled across my front yard. So I understand fear and questions and concerns. I understand, the confusion and being suspicious of all these folks showing up and, so much happening in your front yard and wanting desperately to understand it. So that is, I think, part of what I can bring to the table and help review this information potentially from a community perspective. Okay, so let's talk about the report. Next slide, please. So the East Palestine officials came to task and they posed these four questions for us to keep in mind as we gathered the information. The first question is, what does all this information mean? And good heavens, this came from an abundance of information that was available. So that was the primary goal of the document, was to compile all the publicly available information and bring some sense to it and make it available to you. The next three questions I think are knitted quite tightly together, and they ask questions about basically the completeness of the data, of the monitoring. Are there information gaps? Are there key questions we still need to ask? And maybe additional information that is needed. This comes from being concerned that everyone wants to be sure that the spill and the controlled burn are completely understood. Because when a remedy action comes into place, we want to make sure that action is complete itself. None of you folks want to see any residual contamination left behind. We want to make sure everything is done fully and completely. So these last three questions are when we here at SKIO put on our scientific hats and trudge through all the data to determine if there were any gaps or additional questions that need to be asked. Next slide, please. So in order to answer that first question, what does the information need? The first thing we had to do was find out just how much information we had. And there was quite an abundance of information. But the tactic we took was to access the publicly available resources, the resources you folks have access to. I wouldn't know if there are other collections of data unless like I said, the only thing that we have access to are basically internet-based resources similar to the community themselves. So that's what we got our arms around. Next slide, please. And what we found was an abundance of work accomplished by a fairly long list of federal, state, and sometimes county level regulatory agencies. And so I'm sure as you folks got online and started running your own queries, asking about what are the soils data, what is the air data, and you start tripping over some of these websites by a regulatory agency. And I call this traveling down a rabbit warren. Say you started on the EPA website looking for air data, you'll find an abundance of information is available. Then what you would also find are links to these other agencies. And this can be both reassuring and overwhelming. Reassuring to me because there are multiple agencies conducting work out there, not just the EPA, not just PDEP, not just Ohio EPA, all of these agencies. And so it's kind of like duplicating work. And the more work that is accomplished, the more resolved you can be about the results because you have many data sets to rely upon. So that's the good aspect. The somewhat frustrating aspect can be when you go down, like I said, the rabbit warren of one resource agency and you trip over another and another and another. You start to get a little panicky, wondering just how much is out there and how you are possibly going to get your arms around it. But that, I hope, is what the document serves to accomplish. We tapped into all these available resources and we mashed them down by environmental materials so that you can look at the summary for, say, soils and find every last agency that conducted sampling, and their results will be in this document. Next slide, please. And so let's just step back for a minute. I want to describe for you the process that we take when we're dealing with contaminated sites, such as an emergency response and your incident. Sorry, my computer is showing me all kinds of fun messages here. Okay. This is what is called a conceptual site model, and while it seems like a very simple diagram that depicts the train spill and the controlled burn, it's sort of a map that keeps us in check. As a scientist who goes out and investigates these type of contamination releases, this tells me where to look, what to sample. And then when I get to the end of the day and I revisit those questions that the East Palestine folks asked me to answer, like, are there gaps? Are there still more questions? I keep revisiting this conceptual site model to check myself. I want to make absolutely sure that we are exploring and understanding everything we possibly should as part of this environmental data review. So let me just walk through this conceptual diagram. Like I said, it's very simple, it's very conceptual, but it kind of tells a story and it shows pathways of contaminant migration. Starting with a train derailment to the left, the spill was released and contaminated adjacent soils and continued to affect adjacent surface water bodies such as Leslie and Sulphur Runs. When spills of this kind are released to surface water bodies, they'll float along in the surface water itself and also bind up in the sediment that lies underneath. Back at the spill, if there is enough spilled materials on the soil, they may saturate the soil and transport down through the soil to the underlying groundwater. And groundwater is simply water that is subsurface, saturates the ground. And the important aspect to groundwater, such as for your community, groundwater is your potable supply. That is your drinking water. So it is very important that we understand if that contamination from the spill possibly got through the soil and into the groundwater because we need to know if drinking water has been affected. So those are all pathways that I just described related to the spill. Now let's back up and look at the controlled burn. The vinyl chloride was ignited as a controlled burn to abate an explosive hazard. When you burn a petroleum hydrocarbon, such as vinyl chloride, you'll have ash and soot that will be released to the atmosphere and ultimately will settle out in particulates, probably on soils somewhere else, or plants and any media like, excuse me, materials like that. So that's another pathway that we need to look at. We need to look at where those the soot particles and the particulates could have gone, and make sure that we've sampled the soils and perhaps the plants that were affected. So those pathways I just described, that is a map. That is the map for scientists out in the field to take samples and where to look. And it is also a map, like I said, checks and balances that we came back around to revisit, make sure that all these environmental materials were adequately sampled and characterized. And indeed, there was an abundance of information for these materials, including air, groundwater as drinking water, soil, surface water, sediment, and biological components such as crops and fish. Next slide, please. This is a summary of what we found and who accomplished the work out there. There's quite a few agencies. So you're looking at a summary on this table of federal, state, and sometimes at the very local level of cities and counties. The folks that went out there and captured samples and conducted monitoring and made available their work on public resources. So you should be able to tap into any one of these data resources, and what you can find here is, for instance, what was a primary concern was, of course, air. A number of agencies were concerned and wanted to make sure the air from these chemicals was okay after, for the community and others. Drinking water had a huge concern because when those materials got released to Sulphur and Leslie Run and possibly moving downstream all the way to the Ohio River, a number of folks use the Ohio River for a drinking water resource. So you'll find a lot of data available for surface water, in particular to look at the drinking water concerns. A few agencies also just finished with some biological sampling, including fish and plants, and I'll be talking about that as well. So this is a summary of the data resources that are available, and the document does provide the links to each of these agencies in case you want to dive into them and find all these data packages yourself. Next slide, please. All right, let's dive into the results. I presented this discussion to the East Palestine leaders a couple of times, and they gave me some recommendations how to approach this information, which leads us to the next slide, please. I don't want to, burden my audience with a lot of time talking about the methods behind the research and so forth, and then, belabor the point going through each environmental material, which I will in a minute. But I want to jump to an overall result conclusion so that we can just, get right to the end here, and give you an understanding of what we're looking at. And I thought this graphic was a perfect representation of what we've seen with the data for all the environmental materials: soil, surface water, sediment, groundwater, air. The data all shows a very similar pattern to what you're looking at here on this graphic. So let me walk you through this. First of all, in the top center, what you're looking at is a map, and this is from the Ohio EPA surface water database, and this is publicly available. But this map shows you some green dots and blue dots, and these dots all represent sampling locations where Ohio EPA went out, grabbed samples, and conducted analysis looking for the chemicals related to the train spill. Now, the graphic below shows results from the analysis of one chemical, vinyl chloride, the principal bad actor, and how vinyl chloride was detected in surface water over time. So first of all, look at that graphic to the far left. And what you're looking at is results over time. Samples are taken at each of those black dots, and they start on the far left the day or 2 days before the train derailment and continue all the way to the right until I believe it's April 27th. And so each of those black dots is a sample taken, and you're looking at the results over time, starting before the derailment until well after. So this footprint, this signature that we're looking at, we're the days before the derailment, there's no vinyl chloride to be detected in surface water. The derailment and the spill occur, and so there's this big leap where vinyl chloride jumps in concentration to about 250 micrograms per liter or parts per billion, and then quickly plunges. It drops down to 223 within a day, and then finally just drops down to basically below detection limits, detectable levels, until current day. And that is what I call a chemical footprint, and it is very common for these type of chemicals that are associated with the derailment. What was released from the derailment were a suite of chemicals that would be referred to as volatile organic compounds. And people recognize what volatile means, and it means unstable. It will basically impart to the atmosphere. So when it starts as a liquid, and then it will volatilize to the air quickly. And that's what you're looking at here. These chemicals fell apart fast. They were detectable in large concentrations and then, like I said, degraded or fell apart into pieces. So the next question that a lot of communities ask is, well, that's nice, but are the degradation products of vinyl chloride a problem? And it's a very good question to ask. Well, vinyl chloride, like I had indicated, is what is referred to as a petroleum hydrocarbon, and that means that it is a chemical with carbon, hydrogen, chlorine, and a few other things in much lesser concentration. But those small pieces of vinyl chloride literally are a lot less to worry about than vinyl chloride as the parent compound. So, yes, indeed, for this type of chemical, when it falls apart, when it degrades, that is better. That is a good place we need to be. So, standing back, I wanted to jump to the overall results. I know this is a graphic that just captures surface water and it just captures vinyl chloride, but it does capture the trends in the other data for the other environmental materials quite well. So that's the overall result. Now let's dive into each environmental material piece by piece. Next slide, please. Air was, the biggest concern immediately. As I said, the emergency responders showed up, and that was the first thing that they test before they ever, touch any hazardous release. They wanna make sure the environment is approachable, and so they use handheld monitoring devices, and they test the environment to see if they can actually approach it and start about their work. Um, Now, I want to define something right up front. There are two categories of air information. There is air monitoring and air sampling, and they're a little bit different. Air monitoring is the use of handheld meters or mobile type devices. I'm sure you've seen some of these around town. Their monitoring equipment basically pulls air across sensors real time, and they will tell you real time if there is an air hazard. And that's why those monitoring devices have been placed all through town, placed next to the removal action areas, because we want to be sure that the air is safe for folks to breathe and go about their business. So, monitoring involves equipment and real time analysis. Air sampling, a little bit different. And there's a nice picture here of a canister device. Air sampling is the physical collection of a sample that is taken to a laboratory for analysis. And the reason we do sampling is because the laboratories can run a full suite of chemical analysis of a very long list of chemicals and look for these chemicals at very low concentrations. So, sampling gives you a very refined data set where you'll have a very complete understanding of the chemicals that are detectable, and they will have been analyzed for at very low concentrations. So there's a place for both strategies. The monitoring is very useful to understand if the immediate area is safe. The sampling is used to understand completely what chemicals are present and at what concentrations. Next slide, please. In the document, we compile the available information that was posted on various websites through August 1st. And so, what you will find are a series of maps and a whole sequence of tables that provide the data for you. But what you're looking at here is a map taken out of the document, and it shows an example of the air sampling and monitoring locations located throughout the village. And then the document goes into a description of the types of analysis that were completed as well as the results. The results show that volatile organic compounds were detected above protective levels for human health on dates surrounding the controlled burn and some of the cleanup efforts, the removal actions. The samples that showed these elevated concentrations are typically in very close proximity to the derailment. Um, Let's see, the potential impacts were generally very short term, and I could not find any indication of hazards where the monitoring indicated that folks needed to be made aware of something unusual happening. So, any of the air quality concerns that were detectable in in the data showed very short term episodes of problems. Next slide, please. Here is an example of the EPA air sampling dashboard website, which is probably the most robust source of air data. And this is a publicly available resource. The information on this snipped shot is about a week old, so some things may have changed. And what this dashboard site is showing us is that there were over 14,300 samples collected to date, or as of last week, with 153,000 lab results. Now, what you can do as someone who wants to access this and see what the information is about is that you can click on the map that's shown to you in the center of this image, and those are locations where samples or monitoring took place. And so if you find a location that's of particular interest to you, you can click on it. And then what will happen is off to the right, it will list all the samples or the monitoring stations associated with that location. And then further to the right, you will see the lab results by chemical. Next slide, please. All right, next environmental material of particular interest is drinking water as groundwater. Drinking water sources in East Palestine and other drinking water sources downstream of derailment are constantly being monitored. Sampling has also been completed for private wells within the village. Those private well data packages are available to the well owners, and those are not publicly available to us. Publicly available sampling data from water supplies basically shows, in a nutshell, that there are no derailment or controlled burden chemicals of concern impacting these sources. Let me show you a schematic of how this information is collected. Next slide, please. Okay, what you're looking at here is a map of the groundwater resources associated with East Palestine Village. This came from Ohio EPA. Let me walk you through what you're looking at. Um, the blue polygons, let's start with the upper left corner, the very light blue area. This depicts groundwater in your area. And you'll also see the black arrow that depicts the groundwater flow. So groundwater behaves like surface water. You know, surface water flows downstream. Groundwater does too, only it's subsurface, so it's obviously difficult to see, but it does follow the course usually of surface water drainages very closely, and it does have flow. So this groundwater resource flows in the direction towards the southeast, and that dark blue area, that is referred to as an aquifer, which means that is the portion of groundwater that the East Palestine community uses for their potable supply. As depicted by that orange colored well symbol, your municipal supply comes from a series of wells that tap into that aquifer. Okay, now keep in mind, groundwater flow starts in the upper northwest corner and flows to the southeast. Now let's look over to the right side of the map where the derailment occurred, that red star. We are very concerned and want to make sure that the spilled materials don't reach your aquifer. And so what has happened is that Ohio EPA and others have installed monitoring wells, and monitoring wells are put in place to intercept the potential pathway between the spill site to the aquifers. So if that spill could travel from that red star towards the west, those maroon colored wells should intercept that and let us know that something is coming. There are approximately 8 monitoring wells in place, and they've been online for a number of weeks now, sampling the groundwater to determine if any derailment chemicals are detectable. Again, the fortunate thing is what we've got going for us, the hydrology shows that the groundwater flows in the opposite direction. So the spill materials should not literally be going upstream or up the groundwater. They should not flow that direction regardless. But just in case, those monitoring wells are in place to let us know if something does manage to get through. Next slide, please. Okay, here's an example of a drinking water database that is available for you folks. This captures the East Palestine drinking water wells, that orange well that we just looked at. And this captures what is called raw water. This is the water that comes straight out of the aquifer pre-treatment. All of our drinking water, when it comes from public supplies, is pre-treated. These water treatment plants basically settle out the suspended particulates. They will also polish off the water quality to make sure everything's in balance, perhaps amend the water if it needs. But that raw water is just bulk water straight out of the ground. Now, as per Clean Water Act law or regulatory law, this data is available to you at all times, not because there was a train derailment or anything else going on, but the data that describes your potable supply is a public resource at all times. So this information is available for you to access so that you can understand what your drinking water looks like. Now, what I've done is I've taken the table that you see in the center lower portion and I just kind of expanded one row of information so you can see an example of what is provided for you. And this data shows a sample that was collected back in May at one of the intake wells, and there was a chemical detected called cis-1,3-dichloropropene at 0.779 micrograms per liter or parts per billion. And this all, and as a member of the public, you'd think, well, wait a minute, that doesn't sound very good. I don't know what that chemical is, but it's in my drinking water. What does this mean? Well, what's beautiful about this is that your treatment plant operators take the data and do some interpretation for you so that you can understand what that data means. This chemical in particular is associated with farming and the control of nematodes, and it's a common contaminant that, we as humans just have to deal with. It is not associated with train derailment. So these are wonderful data sets for you to access. They are publicly available, and they do describe to you your drinking water resource. This data set is pre-treated. There's also additional data sets that demonstrate the post-treatment. After the treatment plant polishes everything, the data quality is much better and well-balanced for you. Next slide, please. Surface water and sediment. There were initial samples taken almost immediately after the spill, and they were co-located together, meaning when a surface water sample was taken, the immediate sediment closely located with the surface water was also taken. And sampling was conducted along the streams where materials could move downstream, possibly impact drinking water supplies, and so forth. There's a limited amount of surface water and sediment data available right now, but there is a lot forthcoming from a number of entities. And so I'm going to show you some results. But the EPA has really robust surface water sediment data set that is coming available soon. I did not have it in time for this document. And also, there is a watershed scale surface water sediment sampling program that I'll talk about from the Ohio EPA that's forthcoming. Next slide, please. So the document provides a summaries of the data available to date. And what you're looking at again is a map that shows the sampling locations. Starting at the top, you'll see a slightly gray box that's blown up to the left. There are a number of sampling locations in very close proximity to the derailment. And then if you step back and look at the larger map, you'll see that samples continue down gradient and ultimately to the Ohio River. Embedded in this map are the results of some of those initial samples that were taken within hours of the derailment. And these may be hard for you to read, but in essence, let me give you a summary. For the samples that were collected, approximately 133 chemicals were analyzed for. A full suite of chemicals were looked for, but only a few were detected. Approximately 14 chemicals were detectable around the derailment area. Next slide, please. And here is an example of some of the surface water data sets that are available. I've already shown you this graphic, and I'm showing you a little bit more information about this resource. The Ohio EPA provides for you these graphics so that you can see chemicals over time. They're still sampling. It's part of their sampling program to always be looking in this area anyway. So you can get on the Ohio EPA's website, and if you look at the very bottom, you'll see that vinyl chloride is the tab that's highlighted. So those are the results that you're looking at. But there is a tab for all the other chemicals that were associated with the derailment as well. So you can click on those tabs and see how any or all of the other chemicals behave as well. What the Ohio EPA does, which is very nice to help you interpret what you're looking at, You'll see that green line on the graphic, and that represents the Ohio water quality standard of 16 parts per billion. A water quality standard is a value that represents a safe level. So long as vinyl chloride occurs below that concentration, things are okay. So that helps you understand what's happening. That yes, indeed, the spill released a significant slug of material. However, as we were discussing, vinyl chloride being unstable fell apart quickly, and now the concentrations have repeatedly shown themselves to be basically below detectable levels through the end of this graphic. Next slide, please. Sediment. Sediment was also collected around the derailment site, and you're looking at a map that I pulled from the document again that depicts the sampling locations. There are only a few data points available for this environmental material at this point, and similar to surface water, there were a lot of chemicals that were analyzed for. For the sediment sampling data set, there was approximately 128 chemicals that were analyzed for, and only a few were detected. This little table shows you a summary where upwards of only 4 out of 129 chemicals were detected. So that's somewhat good news. I mean, looked for a lot of chemicals and only found a few. The amount of information, like I said, is currently limited to just a few data results at this point. However, there is a substantial data set that is forthcoming. Next slide, please. Speaking of substantial data sets forthcoming, I was just absolutely thrilled when I saw this. Thrilled. This is Ohio EPA, and they, as part of their normal routine course of business, they conduct watershed scale water quality studies. This is an example of one that captures Little Beaver Creek, and Leslie and Sulphur Run are embedded in this map. You're looking at the title page from their annual sampling monitoring report and also from a presentation that they provided. But the Ohio EPA every year goes out and they sample at these orange kind of polywog looking locations on that map. And they collect an abundance of information. They collect surface water, sediment, water chemistry parameters that are secondary, such as dissolved oxygen, alkalinity, hardness. They conduct also ecological sampling. They look at the fish, the bugs, the microbes, all of it. And they compile all this information into one bundle. And I have to tell you, if you want to know if things are okay or if things are bad, you need to look at data sets of this kind because you need all those threads of information to come together to understand the entire system. If you just took one surface water sample and the results from it, you've got so little information that it's not useful. If you have all these lines of evidence, sediment, surface water, the bugs, the bunnies, the fish, all of it, this will tell you the story of whether things are good or whether things are bad. Now, this resource, they just finished sampling for all this, so there is a document forthcoming. There's the point of contact through Ohio EPA, but these are public documents for you to access as well. And these folks do recognize, obviously, what has happened and have their eyes open to it. So this will be a very valuable resource. Next slide, please. Soils. Soils are an important environmental material immediately adjacent to the spill. The soils were heavily contaminated. And you're again looking at a map that I pulled out of the document that depicts the sampling locations for which data was available at the time this document was pulled together. And there were 5 samples immediately around the train derailment. These were analyzed for upwards of 128 to 131 different chemicals. And for one particular sample, there were 20 different chemicals that were detected, so a little bit more than the sediment. But what you need to recognize at this point, those samples that you're looking at here capture a point in time shortly after the derailment, and so much activity has undergone since with removal actions that those soils aren't there anymore. So like I said, this represents history, and there is a lot of soils data that is also coming available. Let me, next slide, please. There were some targeted soil sampling efforts, such as the city park soil sampling I described for you for the Easter egg hunt, where EPA went out and captured soil samples in the city park to determine if any uh, of the controlled burn soot or ash was a possible concern. So we got that information, did the analysis, and found out the city park soils were just fine. The soil sampling, this is a media that is so key for understanding the completeness of the ongoing removal actions. So there isn't, not all the data is available publicly yet, but it will be. The data, you have to picture that when they're out there doing removal actions, they're taking samples to understand how far the contaminated soil exists. And when they find the contamination, they do a removal. And they just keep going until basically the chemicals are no longer detected and sampling will be completed. That data set is enormous. It is not available yet. It will be probably in the near future, but only a very small data subset is available at this point in time. Next slide, please. Here is an example of some of the data that's available. There are several soil sampling efforts out there happening at once. Norfolk Southern has their contractors, EPA has theirs as well. They're checking each other's work, so to speak. EPA does oversight to make sure Norfolk Southern's work is defensible, accurate, and precise. So what you'll find is that these data sets are posted, and you can take a look at the results of what Norfolk Southern has collected in addition to EPA as well. These are just partial data sets at this point. Not everything is posted and available as yet. Next slide, please. Soot deposited soil is kind of the conceptual model that is used to define where soils are sampled. Let me describe for you what you're looking at. This is a map that basically defines the footprint of the ash that would fall out from that controlled burn. So that darker area in the middle represents, the controlled burn area. And then it dilutes as basically the wind blows the ash and the soot away from that source. And so that's why you see lesser and lesser coloration. The light gray depicts a lot less soot and ash that could have deposited. So this mapping was completed to understand where the soot and ash would fall out. And then soil sampling was conducted to test, was any of the ash or soot a problem? Are there any hazards, any chemicals of concern? And the fortunate aspect is that there's very little ash and soot that fell out. It was dispersed widely and was pretty low in concentration. And then when you look at the soil results for some of the samples that are available now, the chemicals are basically they're not a problem. They're common and typical to what you would find anywhere that has human activity. So that's very positive. Next slide, please. Biological material. Speaking of that soot map that we just looked at, of particular interest were area farmers curious to know if their crops were perhaps tainted by the fallout of ash and soot. And so biological material in the form of crops was collected by two entities, and they conducted analysis for chemicals associated with the derailment and the controlled burn. And basically, the results indicated that there's nothing associated with the derailment or the controlled burn in the plant tissues. The plants are fine. And what you can do if you would like to see those results firsthand, I snipped out the Pennsylvania DEP map of their sampling, which includes the crop samples and analysis. And this is also an interactive map like the other resources I showed you, where you can click on a given sampling location and it will show you the results by the location, who collected them, and so forth. So you can run queries and download this data and look at it firsthand yourself as well. Next slide, please. Biological material, the fish were actually looked at as well. Immediately after the emergency response, Ohio Department of Natural Resources mobilized to monitor the aquatic impacts on Sulphur and Leslie Run. That's part of their job. They respond to incidences like this. When they gained access, what they did was they looked at the dead fish or anything aquatic that suffered as a result from the release to get an understanding of the footprint of impacts. And so the Ohio DNR, the Department of Natural Resources, they have some incredible resources out on YouTube, if you will, where they've summarized what they've found, the results they came up with, their conclusions. And those are listed in this document as resources for you to tap into as well. Next slide, please. Okay, we've gone through all of the environmental materials one by one by one. Now let's go back to those questions that the East Palestine officials initially tasked to accomplish. And the first was, what does this information mean? Now that we have all this data in front of us, from air to soil to fish, all of it, what does it all mean? Well, let me give you an example of how we pull it together. The purpose of environmental sampling and studies is to determine the nature, extent, the fate, transport, and possible health impacts that are related to the release of the spilled materials. As an example, the air sampling was used to identify immediate risks to human health resulting from the derailment, and the soil samples are used to delineate the footprint of the contaminated soils to ultimately be removed. The groundwater monitoring was used to determine if chemicals from the spill are moving towards the municipal water supply, and if they are, that is when we would basically move into action and deal with the problem. Surface water and sediment samples are being used to determine if spill-related chemicals are moving downstream, again to possible drinking water intakes. There were also assessment of chemical exposure investigations that were completed by Ohio Department of Health and the Pennsylvania Department of Health to inventory the exposure impacts to residents and the first responders. Some of the conclusions they pulled together is that folks showed signs of headaches, irritation, tiredness, and so forth. And those documents, the ACE surveys, are now also available as public resources. Next slide, please. So the first question we've answered up through, we have all the data through August 1st compiled into this document. Now, the last three questions the East Palestine officials asked of us was, are there gaps? Are there more questions? Is there anything we possibly could have missed? And this all compiles, like I said, it knits together where communities are concerned. They want to make sure everything is understood, because there are removal actions, there are remedies being put into place, and we want to make sure they're complete. So again, what we did, the SCIO folks, we revisit this conceptual model, even though it is very simple, and we followed all the pathways to make sure that there were samples that were collected to address these pathways and to determine if the sampling strategy was complete. We also went through the data sets rather tediously. We've got a background in understanding the data to look at the data and understand, does it have good quality? Is it defensible? Is it accurate? Is it precise? And we did do that. And so we went through that thoroughly. We found perhaps some minor information gaps. Next slide, please. And it comes from our background as scientists working on contaminated sites similar to these. For instance, a number of samples were analyzed for what are referred to as dioxins, furans, and polycyclic aromatic hydrocarbons. These are chemical components associated with possibly the controlled burn. When you burn petroleum hydrocarbons, you could create these as a very minor component. And entities did analyze and look for these chemicals. I would just recommend that we look a little bit further and be very aggressive to look at these chemicals in particular, because they can be a problem. Per and polyfluoral alkyl substances. These are chemicals referred to as PFAS. I only bring this up because this chemical group is what is referred to as an emerging chemical group. It is a chemical group that we didn't exactly know what we had and what kind of issues they would create. These chemicals are used to help control liquid fires. They squelch the oxygen out and they smother a liquid fire. They're incredibly useful for that. We have found, however, that these chemicals can move in the environment and basically accumulate in food chains and become a problem. I don't know if PFAS chemicals were used to control the controlled burn. I don't know that. I'm posing the question that this may be something we would like to ask about. In our review of the data, we took a look at those initial chemicals that were associated with the train cars, such as vinyl chloride, isobutylene. And like I said, when they get released to the environment, for the most part, they fall apart into smaller pieces, which tend to be good, or on occasion, those smaller pieces could be bad. Cyanide is a possible degradation product from butyl acrylates, and it's a very, very, very small component to butyl acrylates. So don't be alarmed. But I'm asking the question that perhaps we would want to look at cyanide in some samples to just verify the absence of this chemical. Similarly, metals and nutrients, those are fairly pure products that these trains move. They have to be. You know, their next destination is for a designated use in some production facility. So you can't really have contaminated vinyl chloride. It will not be useful to the next person. So it's rare to have other contaminants such as metals and nutrients, extremely rare. But I still pose the question, being a concerned person, is to make sure that that spill did not release some other things that maybe we didn't know to look for as a possibility. Next slide, please. Additional information of interest to the community. I would impart to you that to take ownership of some monitoring and accessing information on your own shoulders. When I've been working with communities, I find that the communities have faith the most in the information that they acquire themselves and actually shake apart and understand themselves. And so what I'm posing here are some opportunities for you to, tap into the resources and actually do some reveal of information on your own time. And there's remote sensing information that's out there. Like I said, there's some forthcoming biological monitoring from the Ohio EPA. All of these things in combination are very powerful. And if you take the time to wade through them, they will help in understanding. And also, please recognize that you have the regulatory agencies there that are for you. And so, if you've got a question about a particular problem, like some folks mentioned swimming pools or their own gardens, raise those questions to your regulatory points of contact and see if they can help with some sampling to answer some of your concerns. Next slide, please. Back to the document. The document, like I said, is supposed to be a resource for you. So the document describes all those environmental materials we went through, from soils to groundwater and so forth, provide for you a data summary, a data interpretation, but also provide for you appendices where you can tap into the references and resources yourself. And like I said, folks tend to rely or have faith more on information if they're able to understand it. And so that's why we spent a lot of time making sure these resources are in that document for you to tap into so you can look at these data sets yourself and not just rely on the document summaries. Next slide, please. Okay, my conclusions and recommendations for next steps. Next slide. The results from all the environmental materials outcomes showed that footprint that I focused on, I initially described, where yes, indeed, there was a incredible release of volatile chemicals, but as per volatile chemical behavior, they quickly dissipated. The elevated concentrations were short in duration and left minimal residue. These chemicals, the way they behave in the environment, they tend to bind to solids such as soils and sediment. Therefore, the removal actions are focused on those materials. They're getting the contaminated soils out, the contaminated sediment, and so forth. And once those sources are gone, then things will be in good shape. The controlled burn related chemicals were low in concentration, and the soil affected by soot shows low concentrations of detectable chemicals. So overall, we're very, very pleased with the results. Next slide, please. In summary, the task level of concern related to the contamination as we reviewed these data sets, air, drinking water, and surface water, we have very low concerns related to the data that we reviewed. We've got low concerns also for sediment, soil. I have to be determined there because there are some rather large data sets that are still forthcoming. And so would like to be able to integrate those into that and include that data as part of this analysis. And the biology, I can't emphasize enough, the biology is key, absolutely key. If the biology is showing itself to be healthy, then that kind of tells the story right there. So please keep your eyes on that Ohio EPA watershed scale study or any other studies that show you how the health of the environment, including the biology, is, because that really does finish the story. Next slide, please. Next steps, monitoring is close to completion, I believe. There are still routine updates being posted on those websites, and links to the data are continually being updated. The watershed scale studies are probably close to completion at this point and will be also made available for you. My recommendations, I wholeheartedly can't emphasize this enough, is for you to keep in touch, for instance, with your community leaders and the agency points of contacts, and please remain involved. I know it's frustrating, it's scary, all of it's just something that's pretty hard to, to deal with. But when you start understanding the information, you start to feel better about what's going on out there. So please keep involved. Next slide, please. We'll now open this up for questions and a discussion.
Okay, thank you, Carmen. Before we start the question and answer, I'd like to introduce myself. I'm Chad Edwards. I'm the new village manager for the city of East Palestine. I started on November 1st, and I'm very happy to be here. This is a wonderful town, and I'm glad to be here, and I'm looking forward to working with everybody. Okay, just a reminder for these questions, they need to stay limited to the data that Carmen discussed. With that, I will go ahead with the questions. Okay, Carmen, okay, the creeks that we had independently tested showed benzene. I want to know if the data matches what we have found. The benzene was high levels.
Yes, I'll have to, okay, the creek data, what I have available to me is a fairly limited surface water and sediment data set right now. And I don't recall benzene being detected. It wouldn't be surprised. It should be detected, honestly. Benzene is a degradation product of vinyl chloride. Vinyl chloride will decay into benzene, toluene, ethylbenzene, and xylene. They're called BTEX. So I wouldn't be surprised to find it. And benzene is a carcinogen. So the protective health levels for benzene are very low to, try to address the issue of cancer. I can't answer if what I saw compares to your results because I don't have your results in front of me. But if you take a look at the document and you look at those results in that document and you've got questions, please reach out. We're glad to carry this discussion further. And also don't forget that there is 2 rather large watershed studies where benzene will be a chemical to be analyzed as a part of those studies as well.
Thank you, Carmen. Okay, next question. The points where the soil was tested at the park was tested anywhere It was tested where the flooding was. Again, independent testing shows that it's contaminated.
Okay. So there was, I'm not sure the footprint of flooding. Was there flooding in the city park?
Um, that it says that the question says the points where the soil was tested at the park.
Oh, okay. So, okay. So some of those sampling locations where tests, where samples were taken were flooded. And so the concern may be that those soils moved and maybe created a problem somewhere else.
That's how I take the question.
Okay. Okay, good. Well, yes, there shouldn't be a problem because those soil sample results came through in good shape. The chemicals were very, very, very low detections, and the chemicals detected weren't necessarily related to the controlled burn. These were chemicals that they come as a release of burning fossil fuels from our own vehicles, for heaven's sake. So to say absolutely that the chemicals were associated with the derailment would be a reach, or excuse me, from the controlled burn. And regardless, your question, if those soils moved, would those soils create a problem further on? No. Those soils had very, very, very low concentrations, and we found them to be fine as is for that Easter egg hunt to commence.
Okay. All right. Question number three. Did you look at independent testing?
Independent testing, like a independent laboratory, perhaps?
Yeah, I mean, I think that it says, did you look at independent testing? I take that as a question as to was the testing you looked at independent, I guess.
Yeah. Yeah, I mean, I'm very, very aware of analysis and interpretation. I used to work in a laboratory. So when you say independent testing, see what happens when soils are collected, whether it's Norfolk Southern or EPA or whoever, those samples get sent to a lab. And when they show up at a lab, they get processed through analysis and they have to follow methods that are prescribed as per standards. It's very tedious, stepwise process to ensure good quality data. And so I looked at a lot of the raw data packages to just make sure that these are results I would expect, that sampling was completed completely, and looked at the quality of the analysis. And I had several labs worth of data to look at. For instance, the soils. We had, I think, 2 to 3 different labs for the soils. And so we compared the results between the labs to see if they agreed, disagreed, or was there any quality issues, and truly did walk through those data packages in raw form. It was quite tedious, but I have faith in the analysis that came from those laboratories because the data packages were defensible. They met standards of precision and accuracy. So those are good data sets. And then, like I said, I'll also consider that if you step back for a second, if EPA went out and collected errors samples, so did other agencies, and we took all that information and compared the sources to each other, and they were in line with each other. So it's like everybody's work checked everybody else, and that was just something that we did to make sure the data was robust and true. And we carried it through even further. It's hard for me to describe all the steps that we did. One of the first questions that I answered, I wanted to make sure that the sampling that was completed was absolutely robust and complete. And so I looked at the maps where samples were collected, and I looked at the distribution, and I made sure that, okay, that soot plume landed here. Where are all the sample locations? Are they truly within that footprint? Just to make sure of completeness. And same with the surface water and the sediment and so forth. I mean, if I were the person given that field sampling opportunity, where would I take samples? And I was pleased that the sampling programs, the monitoring programs are very complete, very defensible. And then you take that next step to look at the data packages, and we did crawl through those. Those are very solid data packages as well.
Okay, thank you, Carmen. This next question I'm going to go ahead and field. Why was the United States Coast Guard pumping sediment out The answer is that the Coast Guard has been on site since the inception to support the US EPA in a health and safety capacity only. Okay, I believe that's all the questions we have. I want to thank everybody for joining us this evening. And remember to check out the website.
Oh, next
Um,
slide. Here we go.
yeah, sorry. I'm sorry. Just the next slide. Okay. Remember, check out the website. It's right there for you to look at. Um, there's also a QR code there. You can scan with your phone if you want to bring it right up. Um, the task will be continuing to support East Palestine, and this webinar will be put on our hub. So with that, I believe that concludes our webinar. We got
Thank you.
Okay, I'm sorry. We have one more question before we go. Carmen.
Sure.
Okay. We have a number of underground coal and pottery shafts in East Palestine. Might toxins collect here to impact groundwater and city water later?
I'm sorry that what was underground? It kind of broke up there.
I'm sorry. It says we have a number of underground coal and pottery shafts in East Palestine.
Ah,
Might toxins collect here to impact the ground and city water later?
Okay. So you've got open shafts, which can serve kind of like French drains for, the groundwater and possible, derailment chemicals to settle. Is that the question? Okay.
Yeah.
Um, yeah, I mean, that's a possibility, absolutely, if the contamination made it that far. So what we need to look at is go back to the soil area where there's a ton of removal actions, that are ongoing or I'm not sure status and completion. But if we remove the source, we remove the spill and the saturated soil, there shouldn't be chemicals that move anywhere. That principal pathway that we're worried about is, did the chemicals absorb to the soil, travel underneath the soil into groundwater, and ultimately to drinking water? That was the primary pathway of concern. We found that that pathway doesn't exist. The groundwater, for one, is going the other direction. But for two, just in case, we've got 8 monitoring wells to test that question. Back at that map, if you look at the document, you'll see that there are additional wells on the other side of the derailment location, basically going with groundwater flow. So the idea behind those wells on the other side is to capture your question. If contamination from that spill is going to move anywhere in groundwater, it's likely going to go to the east. And look at that map. There's 2 wells that are on the east side, and there haven't been any detected chemicals from those 2 wells either. I concentrated on the drinking water question during tonight's presentation, but there is groundwater information available about those additional wells that would capture the pathway that you've brought up to the east. Now, it would be interesting to understand is where those shafts are in relation, to test the theory. I hope that answers the question a little bit.
Okay, thank you, Carmen. Okay, I want to remind everybody at this time to keep your questions limited to the data. Again, that's all that Carmen can address. Okay. Okay, the next question is, will there be any air monitoring inside homes?
I don't
Oh, I'm
know.
sorry, and she
Yeah.
corrected. I'm sorry. Will there be any air sampling inside homes?
I don't know. I haven't read anything on the websites from the folks doing the sampling. I don't know the answer to that. I'm sorry.
Okay. Okay, thank you. Okay, do we have any other questions before we wrap up? Okay. That concludes our webinar. Again, thank you, everybody. And the information is right there on the screen, and the QR code is available for you. And again, a reminder that TASC will be here continuing to support East Palestine. Thank you.
Thank you.